Today it's just a quick talk for me about how important I am, and then we're going to hear about some really important stuff. Georg and Dave have started a company that deals with particular accelerator communication based control system. Oh yes, it is rocket science. So he will be talking for a bit, and after that we're going to have Pictures Corner in there. If you want to listen to that, we have 4 pictures, you are welcome to join us. It takes 1.5 hours, so if you have class, don't bother. Neil is going to be there as well. Neil is an American, so he's quite exotic. Yes. Well, he looks nice. He speaks nice as well. Anyway, I'm not going to ramble on. Good to have you here. Speak to each other. There are things going on in the buildings afterwards. Take a walk, look around, speak to people. But first, listen to Georg and BLM say. Big applause! Way!
Yeah, good morning.
Good morning.
Thanks, Belle, for introduction. Actually, Belle didn't pitch our product very good because it's not as complicated. You know, it still has some accelerator background, but I will come to that. Why I'm talking to you today is because before the summer there was an event from Ideon Innovation, a summer party, and there was Johan from Upsalt, and he talked about he wanted to hire a software engineer. And then after the party I went to him and said, maybe I know somebody, but why do you want to hire a software engineer? And then he said, well, you know, we're building an application that needs to have a control system, and we want to build our control system. And then I said, obviously you don't know what we are doing because we are building control systems, and we are better than everybody else that build control systems. So why are we not talking together? So that's basically where this idea started to come here to the Ideon Breakfast to tell people what we are doing. And indeed, you know, we offer you a service to build a control system for your applications that is based on our control system that we have developed over the years, which is very, very powerful, and which, as Belle said, comes from accelerator controls. Okay? So let me run through. My name is Georg Kula. I'm the CEO of the company. I'm here together with Dave McGuinness, who is our Chief Technical Officer, who has developed the system. And yes, so the company is called BL Monitor and Control. BL stands for Blinky-Lite, which is the name of the control system. So we are a spin-off from the big facilities out there, Max 4 and ESS. That's where we basically have gained our experience also over the years from CERN, Fermilab and so on. I want to highlight the expertise that we can bring in, because many of you need this kind of expertises. So we cover a wide spectrum of fields that starts from electrical engineering over RF design, which is radio frequency, renewable energy, ultra-high vacuum, software programming, cloud computing and machine learning. So we can cover the whole spectrum from a sensor up to the integration to the internet, and basically also extracting the data and training systems with the data. We have over 40 years of experience, and I think we're quite good. So this is our team. Me and Dave I have already introduced, and Daniel Everett, he's a Swiss guy, and he's also supporting us. I talk now a little bit about the control system, that you know what it is all about. So this system is, we call it the first full stack control system that is based on edge computing. What means full stack? Full stack means that there is something that is already covering the system, like alarming, data archiving, all these things, they are already there. And what we need to take care of is only the interface to your device. So again, full stack from top to bottom. We provide everything an engineer needs, from the device hardware to the interfaces and the user applications. And this includes these features like alarming, access control, setting history, archiving, and so on and so forth. So typically things that you need to control your application in a safe manner. What makes us really different from everybody else is that we are totally open source. Okay? So if you go to Siemens or if you go to ABB and these guys, you get a proprietary control system, and after 10 years you get into troubles. That's what we can see with a lot of companies. They say we have a problem because we can no more access the source code. And the people that work with us, they're already gone. So in our case, you will be always able to go in GitHub and see the source code. It has, because you know the architecture, how we architecture the system, we use this principle of edge computing. That means we can put the device controllers very close to the devices, and this gives an additional layer of security and reliability. You can think of an orchestra when you have a conductor and you have the musicians. In our case, the conductor just starts the music and can disappear afterwards. The musicians, they still know what they need to play. About security, because we always asked about security. So our philosophy is that we would like to control, actually we control every application via our phone, via smart devices, but it can also be controlled via a desktop computer. And then comes always immediately the question, what's about security, right? So now people using this device also to transfer money, right? Everybody has an online bank. So we use the same technology that online banks, and in addition we have on the ground layer a technology that's called MQTT that allows to open the communication from the inside out, which basically allowed us to have a system at CERN, which is really the Alcatraz of internet security. So we are scalable. Basically we can start from very, very small applications where we have 1-2 sensors up to, we have just recently completed the control system for a particle accelerator in Hungary, where we have a few thousand of devices that basically provide data and need to be controlled. Here you can see the architecture. So basically the full stack, this is the center of the system that's already all developed. Also the user interfaces, and as you can see we can go from the device, which is a simple LED, to some machine, to a factory. So we can cover the full spectrum. So what do we offer? We build edge computing solutions that allow to control your ideas or your applications. This is how we do it. We implement measurements with our system in short time. We are very fast. We can help customers to pick the right sensors, because this is also, you know, IoT provides you endless amount of sensors, but it's difficult maybe for you to choose the right one. So we can give you advice on that as well. We also help the customer to analyze the data and understand, you know, where you should basically focus on. And we always follow this principle of form follows function, which basically means we build only what is really needed from the customer. And we don't provide you endless features that you are never going to use. So that's why we can be fast, and we can also be cost efficient. So, as I said, we are fast. You don't need to hire an army of controls engineers. So let me give you this parallel example. For example, why are people not building their own web servers, right? Amazon, they came up with this idea of hosting their own web servers, and they did this because they are better than everybody else, and people basically went to them instead of everybody building their own web servers. We are a little bit the same. We are the best in building the control systems. We are fast. We have the interfaces ready for you to connect to your devices, and we are requiring also minimal infrastructure. So we can run on very expensive computers, but we can also run on very low-cost computers. The full system that I'm talking about has a footprint of 75 megabytes only. We are ready on day one, so we can really focus on the implementation of your idea. And we basically let the engineer concentrate on the facility instead of debugging the control system, which to our experience takes a lot of time and takes a lot of effort and resources normally. I give you a very brief overview of a system that is basically for an RFQ, which is a radio frequency quadro board. And this is part of an accelerator where we built the full control system in Hungary. And just to give you an idea, here we have built hardware and software for this device in less than 3 months. And this because the lead engineer that was supposed to do from this company, a Japanese company, could not do it because of Corona, so he had to go back to the US. He left the company without any documentation. We started from scratch, and we delivered in less than 3 months the following system. So here you see this is the RFQ, which is a big piece of very well machined copper. And you see it has all kinds of devices. It needs cooling, it needs vacuum, it needs pumps, it needs all kinds of controls. It needs to have radio frequency, low level RF control system, and so on and so forth. So what you can see here is basically these flow meters that we are controlling. We built our own hardware, 2 layers, PCB. So that was all done in less than 3 months. Here you can see an example of a vacuum system. For example, here you can see, which is called the Controlin Omega. It's a device that is similar to a PLC from Siemens or Beckhoff. However, it's open source. Okay? So it can replace, it has similar functions than a PLC. However, it can replace a PLC and it can go into industrial applications. It's industrial certified. And this, last but not least, this is the RF regulation. And here we're using real-time processors, FPGAs. And yes, so I think that was a quick overview. What we have also done, and maybe somebody of you is interested, we have, due to these high energy prices, we have built a suite of devices that can actually be steered due to the current energy price, to the spot price. And we have made this open source, so everybody that is interested in to build a device and steer it at home, basically we can show you how to do it and where to download the information. But I think that's something that we wanted to do because of people suffering from this high energy price. So what we do basically, we go in the internet, we have a virtual sensor that picks the information about the hourly price of the electricity, and as you know it's 24 hours in advance defined, and then we basically can say, you know, when the price is going up and down to just switch on at a certain level, or when the price is the lowest, and so on and so forth. So it's open source. Everybody that wants to build is invited to participate here. Okay, I hope I gave you a quick overview of what we are doing, and we have a few devices here. If you're interested, please come and talk to us. And otherwise, we have our office inside Ideon Innovation. I hope that everybody now knows that there is a company that is doing control systems that can help you to implement your ideas. Thank you.
Thank you.